it out again. So,
Okay. Oh, excellent. All right,
so
we're recording
anyway,
now. Excellent.
so we're having a conversation about whether and how we're going to try to dim the sun. There's many, many technologies. And I think Richard should talk to us a little bit about the document he sent to everyone, which was, if you don't mind me surmising it, was a description of at least 10, maybe 20 currently proposed aerosols that you would put in the atmosphere. Most of them from high up. In one example, from low, from the ocean up, and there's various particle types, and what ways they would be complicated, difficult, useless, problematic, fall out of the atmosphere too soon, et cetera, et cetera. And I think since Richard wrote something extensive, we should give him the floor and explain what he did.
Certainly. And welcome, Dave Stutz, for joining. Thank you.
Thank you,
Yeah,
Dave.
took me 10 minutes to find an email with the link.
Oh, yeah. There was a single letter off in the link, and so it threw the whole link off.
Right.
Was that David?
Yes, David.
Yeah.
For some
Yeah.
reason, he got screwed up. Go ahead.
As an aside, Dave, I want to talk to you about solar offline, and none of the phone numbers I have for you work anymore. And I asked Myron for your number, and he never got around to giving it to me. So
I'll send it to you.
yeah, okay, very good. All right, now since I was asked to speak, I'll talk a little bit about this paper I've written. So the basic idea here is fairly straightforward. We've got this kind of concept on the table about dimming solar radiance via changing Earth's albedo, which is the correct terminology to use. And the albedo is essentially the reflectiveness from an exterior point of view. For example, we look up at the moon and we see that, it reflects the solar radiance, pretty well. We can, full moon and so forth. And different celestial bodies have different albedos. And Earth has a particular one that humanity has been altering through our I'll call it inadvertent terraforming. Some people might prefer the word geoengineering, but we've been screwing up the place since the start of the Industrial Revolution. And now the idea is, can we use aerosols to help dim the solar radiance to give us, buy us a little bit of time? And the bottom line answer is a tiny bit. We might be able to accomplish as much as 3%, something like that, with a real concerted effort. And there are a lot of problems with it. And the document I wrote outlines the fundamental issues, of which there are a goodly handful. Most notably, just kind of in real summary form, the issues are, well, what materials should we loft? What will the environmental impacts of these materials be as they inevitably settle out of the atmosphere? What are the least harmful methods of lofting these materials? And given the difficulties of putting the material in the right amounts in the right places, how is it that we're going to be measuring what success looks like and make sure that we don't go astray? Then there's the question of, are there any extant distribution methods for spreading the particular types of materials that would be chosen? And on what time period would they need to be replenished, which has to do with effectively the rate at which they settle out, which is almost but not exactly related to their mass, the particulate mass. And that, of course, has a lot to do with particulate size. And then the final question is, given that lofting the wrong material or a mix of different materials might very well lead to an even worse disaster. We need a political decision-making plan. And I address that first by basically pointing to the United Nations, which has a fairly robust set of features already. And I propose ways to strengthen those political bodies in order to be competent at serving this potential purpose. Then I've got a section where I list 15 different potential aerosols to be lofted.
Richard, I want to tell you, you don't have a screen that can do this. I have your document on the screen, and I'm trying to keep up with you. Keep going.
Oh, great. Yeah. Okay, great. So I rank them by more or less the best mixing, or the mixing is not the best word to choose. At the top of 4, I talk about how they're ranked. They're ranked by the higher the ranking, high to low, by the overall effectiveness, factoring in environmental impact. So top of the list is calcium carbonate. And before I get into all of them, I'll just note that I've got at least one paragraph for each of a pro and a con, environmental impact, strategies for lofting, a conclusion, and then references to sources, you know, where I got the information, some of the better references available. And interestingly, some of the references that I use are in at least one of the videos that Myron has shared a link for us with. Then when I get into these, again, calcium carbonate, one of the great things about it is not only does it have strong light scattering and would help the albedo very much, it also neutralizes acidity by being mildly alkaline and would have minimal ozone impact. Some other choices have no ozone impact, which is also wonderful. The next one down is actually really probably my overall favorite, even though it's ranked number 2. Crushed basalt, basically into a fine ground silicate. It's chemically inert. It's geologically abundant. It reflects sunlight comparable with the best of them. Once it settles, for example, to the ocean surface, which is most of the surface of the planet, it can, first of all, form stable carbonate materials, permanently sequestering CO2, but also its dissolution releases calcium, magnesium, and iron, which can fertilize phytoplankton at the sea surface and thereby help feed the world's fisheries, and provide yet other biological CO2 drawdown pathways. Next is silica, which is basically just sand, chemically inert, low toxicity, moderate reflectivity. And then we start from here down. The choices are, in my view, much worse. Yes, they can be used, but they all have significant downsides, you know, from 4 on. The likelihoods of the wrong choice being made, you know, out of the 15 that are potentially, you know, more likely to be under discussion, 11 of them are bad choices. So, you know, some are worse than others. Y'all have the document. You can go through it yourselves. But the worst of them are probably diamond and sulfur dioxide, which rank similarly badly. the problems with diamond dust is that it will probably never really get a good chance to break down anywhere and will remain diamond dust and provide a microabrasive that was going to have its own major problems, but also because of its incredibly small size, that it is almost certain to act as a catalyst in various ways and just cause all kinds of problems. Sulfur dioxide's worst downside is that it will almost immediately form a strong acid and cause all kinds of problems. And I'll remind you, those of us in the USA, we know about acid rain from the 70s and 80s, which was a horrifically bad thing. And we had to work very hard to get rid of it. And yet sulfur dioxide happens to be like the favorite choice of idiots all over the place. And they just don't know what they're asking for when they try to choose it. It isn't even, it is good. It is good at reflecting, and it is a natural thing that's out there, but that doesn't mean it's a good choice. Then there's, so forth. I'll let you go on and read the remaining ones yourselves. Then near the bottom of the document, I kind of wrap it up a little bit with, let's see, let me
The
scroll
moral
down.
dilemma. The moral dilemma.
Yeah. Yeah, this is basically what I try to point out here is that, yeah, maybe we can do some good with this, but the first section, 5.1, is pretty obvious stuff. If we're reducing solar radiance, we're going to be reducing our photovoltaic and wind turbines,
Yeah.
so forth, are likely to be affected. Hydrologic power will be affected by changing precipitation patterns, and even a nuclear and so forth will also be affected, but less so, but still affected by changes in cooling water availability and things like that. But then when we look at the systemic level issues here, we really boil it down with, points 2, 3, and then finally 4 and 5. We get to, if you read all of that, you'll come to see that that the problems that are created by doing this are almost of the same scale as the original problem itself. And I have strongly stated right up at the top, and it's worth reiterating when you come down to the conclusion, is that the only way that we should ever engage in anything that is this risky, we must fund at least equally as well, if not much more so, to simply stop all of humanity from taking yet more sequestered, stored carbon and adding it to the atmosphere, what's called short cycle carbon, at least at the industrial scale. We just have to stop that. It's as important and more important, even if we were to pull off this damming effect, it's only temporary. The other problem is going to catch up with us. And the second thing is permanent carbon removal from the atmosphere. And I had intended to include a section about that, but the idea is it's already well proven and there have been tests already done, and we know this solution works. And the basic idea is to use, genuinely capture with as low carbon footprint as possible, as much atmospheric CO2 as we can manage to collect, compress it into a liquid form, and then squirt it into very specific types of rock where we already have wells drilled in the ground, and we can inject the CO2 there, and within 2 years or thereabouts, some huge fraction of that CO2 will be converted into forms of literal rock that are geologically stable and will, from humanity's point of view, be completely permanent. I mean, we're talking about millions of years time scale. So that's what we need to be doing, is removing the carbon. We got to stop adding the carbon from the atmosphere. We got to remove the carbon from the atmosphere. And if we're taking those seriously, then maybe we can buy a little bit of time by this dimming strategy. But either way, dimming is just a pretty, weak system, weak strategy. And my concluding sentence, I'll conclude here with, only with a dual commitment can a dimming strategy, if ever employed, avoid becoming a fleeting Band-Aid on a sliced artery, a far too weak effort at addressing a problem that demands lasting solutions.
Okay,
And
thank you.
with that, I yield the floor. Thank you.
Okay, well, I just wanted to introduce some of the content that was the broad stroke discussion of what we're talking about. So let's see, I don't know whether I think I'm gonna have to stop the share and restart it with a different set of content so I can talk about it. So
Well, Richard, I have a quick question while Myron's setting that up. I noticed the
Sure.
formula you're using was something like the benefits or the effectiveness, sorry, divided by the environmental impact. And I was wondering if, when we're assessing that environmental impact, it'd be easy if it was just sort of a straight line of, how, it impacted the environment. But there seem to be so many factors in assessing that. Not to mention, is there like a critical point of no return with the impact that we don't want to cross that would just negate any sort of forming effort,
Well,
geoengineering effort?
I personally have a perception that there is. If this is a scientific paper, you're supposed to keep your own, thoughts on the matter out of it. But I think the last two should never be considered. Diamond dust, absolutely never, never, never.
Sure.
And the same, and the same with, the sulfates. They have absolutely no business being used in this way, because the acid rain problem and so forth is just so terrible. It's devastating of the environment, of human structures. It's just anyone who proposes going there is obviously ignorant of the downsides, and they need to be stopped. They need to be just told, hell no, because there are other choices that are good.
let me introduce the other couple of videos. So this video was so I get this to stop so I can get out of it so I can show you. What happened is I was in, I don't know what's showing. Can you see on the screen what I'm pointing to?
Yes, the link to geoengineering
I
watch.
sent this link about 12 hours ago, and it's called Dimming Full-Length Climate Engineering Documentary. And it's kind of suggests it's very impressive. It's a 2-hour video, and you can watch it at that link. It's a YouTube video. And I can go to it here. You can see it. And I'm not going to make us listen to the whole thing because obviously we couldn't. So the authors of this discussion are suggesting, maybe they're demanding us to believe that the jet engines that we're using to fly all over the place are spewing out these particles very often, all the time, I don't know, some kind of large percentage of the time.
Do not
And they
climate science community and official agencies telling us
they say, you can see this picture.
Oh yeah,
of the
chemtrails. Yeah.
your contrails, that's what they're called, of an airplane. And these people claim to know that's not what would happen if we weren't trying to release an effluent. Okay, if you did it, if it would actually show nothing. And then there are various views where they have skies look like this, and these various people who think there's things going on. And then Lyndon Johnson actually said this, that he wanted to climate change the earth, and that Bill Gates got involved in it. And then there's various engineers who claim they also know that, all these people here say, you can try to do it, but we don't know how it's going to work, or even worse. And then I'll see if I can summarize it. They say that all these trails are not just airplanes flying by, but these airplanes with purposely trying to release their aerosols. And many of the aerosols they were talking about were aluminum aerosols. Here's one person, which I think is very interesting. She worked under George Bush, and she said, and I'm just going to paraphrase it. She said that she wanted to retire from government, so she bought a building, a piece of land in Western Tennessee, and wanted to live there. And as she was driving back and forth from Tennessee to DC, she would see all this ridiculous stuff in the sky, and it got her interest. And the more she studied it, the more alarmed she was, pretty much what she said. And then this is a lead researcher, Dan Winningen. I think Troy said he doesn't really believe everything they're saying, but there's a lot of reinforcing evidence. Another thing that's really emphasized is, you want to say something?
Yeah, I would. Whenever the time is right, I'd like to respond to this. I've watched a pretty good chunk of this video.
Right. So let me just say that many of the speakers suggested the primary effluent was some kind of aluminum compound, which of course aluminum is great for reflecting. But unfortunately, tiny pieces of aluminum are extremely dangerous to your health. I mean, incredibly dangerous to your health. And this has been going on. A lot of people are getting sick, even saying it could be causing Alzheimer's disease. I don't know. Who knows what they know what they're talking about. But anyway, this is a very condemning article, and it really is only talking about one effluent, aluminum oxide or something like that, even though the other ones, as Richard say, have their own problems as well. And then this particular picture is where this guy is doing a bunch of tests, and he actually flies into these clouds and collects particles, and he puts them in an electron microscope. He's actually able to determine what they are, and et cetera, et cetera. So anyway, I don't want to go through the whole thing, but you can see why would there be all these streaks, and if they weren't trying to do something like create a barrier to sunlight.
Yeah.
And so anyway, you want to say something?
Right. Yeah, there are there's more than one potential there. There's Al2O2 and Al2O3.
Uh-huh.
And to most people it's like, yeah, whatever.
Right.
But they're not at all they're not at all the same.
Okay.
And the odds, because of the detail of what they were talking about in the video, they fairly certainly mean aluminum oxide as normally defined, which is Al2O2.
No, BO3, because aluminum has valence +3 and oxygen -2, so it's got to be 2 and 3, not 2 and 2.
I think you're mistaken there for some chemical reason I'm not 100% sure of, but I'm not going to argue valence numbers. However, either way, it's on my list of bad choices for sure.
Right.
However, if you were to try to use it, either one actually, it would here's what you'd see. It depended on where you emitted it would be a large factor in what was going on. But if it was dispersed at the top of the stratosphere, then it would eventually still settle out into the settle out of the upper atmosphere in a few weeks to a few months, and then would join the troposphere and fall the way the other does. However, it would eventually leave a thin, globally dispersed layer of fine white-gray mineral dust, roughly comparable in mass to volcanic ash, from a medium-sized volcanic eruption, somewhere between 0.1 and half a megaton, which is the way they measure some of these volcanic eruptions, if the program were truly, quote, huge. But it could be detected by, also, the local ground accumulation would be a measurable increase globally of the aluminum concentration. It really, I mean, there's not a lot of cross hemispheric flow going on. So given that all of the photography that they were showing was in the northern hemisphere, it would certainly coat the entire northern hemisphere with aluminum oxide. There would be a rise in soil pH, and it would be a visible whitish film on exposed surfaces after a period of deposition. This would be easy to test. I mean, trivially easy, but it would be everywhere. It wouldn't only be in a few locations because it would just be carried around by the winds. It won't settle out quite so fast that it would stay localized. Soil and water sampling campaigns would show it up, namely the CP-MS testing. That would pick up the anomaly. That's a common test. And it would also show up as a surface albedo change of a uniform brightening over large regions. And it would also be visible from space with satellite using, in particular, LiDAR. We have two satellites that could easily detect it. One called Calypso, and the other, a little harder for me to pronounce. It's ancient Greek. Aeolus, I guess, Aeolus. And then there's also Aeronet, which is an aircraft-based LiDAR system that could also detect it directly. And it would give a very specific spiking signal in the returns, and would be easy to pick out as aluminum oxide. So if that was really going on, there would be a significant air quality impact, and the inhalable dust would itself be a considerable problem. And ground-based air quality monitors should be flagging it. Health agency reports should note it quite easily. So if this was really going on, we really ought to know about it. I could kind of go on about it, but I'll leave it at that for the moment.
I want to pause, if you don't mind, Richard.
Yeah.
I have a
Sure.
5-minute video that was put out by Nova PBS about this general technology. And of course, there are multiple ways you can do it. And I don't know if they're talking about everything or one specific case, I forgot, but it's only 5 minutes. So let's play it.
Climate change. We're already feeling the effects of a warming planet. To prevent further damage from human-induced climate change, we need to cut global emissions to zero, something that may take decades. And even then, it could be too late to avoid catastrophic damage. So, is there another way? Climate change is driven primarily by an excess of carbon dioxide in the atmosphere from human emissions. This CO2 acts like a blanket, trapping heat on the planet. So, if we want to reverse the problem, is there a way to just take some of that CO2 out of the atmosphere? Actually, yes.
There's carbon all around us. If you think of trees as a machine, then trees would be a carbon capture machine. When we're looking at trees, about half of that weight is carbon.
Forests soak up carbon dioxide and they put it into wood, leaves, roots, the basic building blocks of a tree. And that carbon is held in that tree.
According to one recent paper, planting permanent forests on the order of 1 trillion trees could erase nearly 1/3 of all human carbon emissions since human industrial activity began. The potential of trees is huge. That paper has met with some skepticism around just how realistic it is. There's uncertainty in some of the measurements, and a lot of the land where those trees could grow is spoken for. People need land to, for example, produce food for a growing population. Some agricultural practices have been developed to enhance the ability of farmland to store CO2 in the soil. But still, what if our natural solutions just aren't enough? Can we engineer an alternative? Several companies are trying to vacuum CO2 straight out of the air. The carbon dioxide that these so-called direct air capture units collect can then be recycled into useful products or sequestered underground. The challenge here is direct air capture takes a lot of energy. And even if it were run on renewables, that clean energy might be better spent powering things that would otherwise rely on fossil fuels. And it would take a lot of direct air capture to make a dent. One company estimates that it would require 750,000 of their shipping container-sized units to offset just 1% of annual global emissions. There is another approach, and it's quite controversial. It's called solar radiation management. And here's the idea. If we can't solve the carbon problem fast enough, maybe we can just make the planet a bit cooler in a different way until we can solve the problem by reflecting some of the heat from the sun away from the earth. Sulfate aerosols resulting from major volcanic eruptions, like Mount Pinatubo in 1991, have done this naturally in the past. We could do this artificially too, by releasing aerosols into the air. Compared to other solutions, it could be relatively cheap and easy, but it only treats one of the symptoms of climate change, not the cause. For example, it does nothing to fix ocean acidification, and it might lead to unintended consequences, like disruptive weather patterns, or worse.
This is a manipulation of the Earth's atmosphere on a huge scale. What happens if things go wrong? Nothing in our scientific capability actually enables us to understand the complexity of the interactions that would be set loose. It's not just that it lowers the temperature, but what are some of the other effects on the hydrologic cycle or on heat waves and droughts?
The root of the concern is that solar geoengineering research, however well-intentioned, will be used as an excuse for big fossil fuels to fight emissions cuts. Solar geoengineering does not get us out of the ethical and physical requirement to cut emissions.
Ultimately, there are no quick fixes to climate change, and we can't undo the damage we've already caused to some communities and ecosystems. So many scientists agree that we must reduce greenhouse gas emissions as fast as we can to limit further damage and adapt to the changes that are already here. Follow us on social to watch our other episodes that dive into those climate solution strategies.
Okay. Thought that was a little punctuation that might be good.
Yeah.
Get this-
Yeah, my gut take on that one is, yeah, so I think we knew that. Tor and I once had a project going for a little while where we were going to use solar. Yeah, Tor, y'all know Tor.
Two circles.
Yeah.
Sorry about that.
What? Yeah. Yeah, Tor and I had a project going on where we wanted to use the winds on in the polar regions to power sequestration and of carbon, direct air capture and then store it. But while there are a few places where you can get ridiculously high winds for extremely long periods of time and use that energy to capture, to do direct air capture. The logistics of it all are really challenging. So, but moving back to this other video we started at, I really have to call bullshit. There's a lot of material in there that is absolutely true, but it's interspersed in an extremely misleading way. And I'm going to bet that the people who are putting that video forward know that they're misleading and basically lying. Yes, I'm 100% sure that the government documents and that, you know, there's a will to try to control weather and everything, because the people putting it forward are not scientists and have no idea what's possible or not. And there are people ready to take their money. That doesn't mean that those programs are going to actually work. When you look at the engineering and the physics behind what's being proposed, there are a lot of assertions that are just bald-faced, holy shit, they said that out loud. Don't they know how that's just completely wrong? Well, they either know that it's completely wrong, or they're intentionally, or they don't know what they're talking about. It could be either one. It's hard to tell with these people. They seem sincere. Some of them may know, and some of them may not. I can't. I'm not in their head. Whatever. But the contrail stuff, they obviously don't have a clue what creates the contrail. It's called contrail because it's condensation, and it only occurs in certain scenarios. But when it does occur, it occurs pretty readily by anything transiting through the aerospace with any form of wing device or whatever, because what causes the moisture, the water vapor, to condense and form a cloud is the sudden pressure differential of the aircraft or missile or whatever flying through the airspace. And that's what causes the condensation. It has nothing to do with engines or all kinds of things. In the photographs that they show, they definitely do have some that are showing genuine dispersal of something or other. Absolutely. But that doesn't mean that the bulk of the crisscrossing of whatever is being shown is real, genuine chemtrail as opposed to contrail, right? And then they get into these things there. I mean, I wrote notes. I'm up to like 59 minutes in it, and some of the claims are just so ludicrous. They're claiming at 49 minutes, 55 seconds in, that hurricanes not only can be, but have been controlled by the U.S. government since at least 1947. I got to tell you, that's a real knee slapper. If you believe that, that's just that, you know, the amount of energy in these storms is so gigantic, and trying to claim that you're going to steer where they're going with some microwaves that are like heating up and cooling down, you know, that like, just no. I'm sorry, no.
Yeah, I'd like to add a couple of points. I wish Paul Washington had joined. He said a really interesting comment about how dangerous the pollution is. But I wanted to point out that there are multiple ways you can do it. We just played the video from the Harvard scientists where they don't like it. And then there's a whole nother way, which Richard did mention and I mentioned, is running ships that would throw water up in the air. This is in this article. It's not a video, but they have ships that spray water up in the atmosphere, and of course not that high because it's a spray system, and they were trying to get it to work. 3.9 thousand square mile cloud creation was what they were going to do, but they got stopped by some people in, I think it was the same county that Troy lives in. And they said, no, you can't do that around us. And it shut the whole thing down. But anyway, I think this is a cleaner way, may have less probability of success, but it's way less probability of causing side effects that are dangerous just by spraying water into the lower atmosphere from the energy you get from a ship, which is what this article is about. But I want to go back to the other thing I was talking about, which is very interesting, which is this thing. I think people are going to say, what are we talking about? And I want to say it's a meta conversation. But before we go down that road, I noticed that we have quite a few people on that we didn't notice at the beginning. We have Christopher Faust, Dr. Saeed, Dave Setz, and if any of these guys want to jump in now, I want to give you a shot. But what I want to do before I do that, I want to just talk about this last section, which is assuming we actually could do this. Okay, we actually could slow down climate change, or at least dim the sun while we were trying to figure out how to do it. We could have a feedback loop, which is really bad. So I want you to think about these phrases. Necessity is the mother of invention. And I'm sure most people have thought about it. You have a problem, you figure out a solution. So that's why necessity creates invention. However, invention also creates necessity. And what I mean by that is if you have electricity, then you'll have refrigeration, food, and you'll have air conditioning and cell phones and stuff. But before you had electricity, you didn't have those needs to have those other things. And so when we invent solutions, we wind up inventing necessity. And it's really pretty much the conundrum, fundamental condition of human life, because we keep making tools, and through that method, we actually create more and more needs. And that may be the only reason why it's fair or reasonable or appropriate to give everyone as much electricity as they want, as fast as they want it, if they can pay the price. And I think this has a meta conversation about the feasibility of dimming the sun, because if we got this technology, you would find places with lots of money like Kuwait or rich people who want to save Manhattan. And I guesstimate you could do a good job of maybe reducing 1 or 2% of the climate change by spending about $10 trillion, which is more money than's in my pocket. But there are people who have money, that kind of money in their pocket. And it's cheaper to spend $10 trillion trying to slow climate change than is to rebuild Kuwait 50 miles from the coast, 10 feet higher in the air. And that is what, I meant Dubai. And I think that's the kind of thing that is going to happen. But when we do it, we'll have this cycle of invention as a mother of necessity, and we'll need more and more of this, assuming we could make more and more of it. We won't really get anywhere, but we'll throw a lot of money at it. I'm just saying that's another view, a meta view of this problem. So I don't know if you think about
I have a tiny, very short comment here about sea level. We're something like 186 feet below the highest known in history,
right.
roughly, and 186 feet higher is possible, and the geologic record does not show any slow, gradual changes through those periods. The geologic record instead shows long periods of stability with very slow change, and then sudden boom, it's at a new level.
Right.
A very substantial change. And right now, there are huge numbers of feet worth of ice stored on the coastlines of the world, where only a few feet of, 1 foot will get you 5 feet might get you 15. And there's a place in South America known as Patagonia where there's a small gap of a few miles wide that if the ocean were to flow in there, it would flood hundreds of square miles that are currently covered by large quantities of ice. And if that ice was to melt by the water reaching it and thawing it, and it joined the oceans, it would mean a pretty substantial amount of sea level rise.
Okay, I'd like to give someone else a chance to talk. Maybe Christopher or Dave or Dr. Saeed, because we've been, everyone else got a chance to talk. Anybody, if you guys want to talk? Christopher, Dave, Dr. Saeed. I'm trying to give you guys a shot.
All right, I'll go ahead and talk a little bit. Okay, so number one, I've personally been considering geoengineering for at least the last 30 years. And I've tried to follow reasonably well, the technological innovations. They're really, I mean, when you look long-term wise at what the problem is, we have essentially got to take 200 years of carbon out of the atmosphere. And we don't even know if we did that it would forestall some of the changes that we see happening right now. And I shudder to remind you of this, but we are in an ice age. And there are several times in, the recorded history where it got this hot and then it got really friggin' cold for 300 years. So I'm resigned to the idea that we're going to try to affect some type of geoengineering. I'm much more inclined to look towards, mylar cells and things like that we would deploy between the earth and the sun, and really focus in on peak intensity times, maximum summer in both hemispheres, so as to mitigate the peaks. And I think if you did that long term wise, with some kind of L1, positioning of a sail, you could affect long term heat index as far as the planet's concerned. You're still going to have the carbon in the atmosphere, unless we come up with some kind of magical technology that I don't know anything about yet. And it should be noted that the principal cause of the bulk of that energy or the carbon that's in the atmosphere came from principally the United States over a 40 or 50-year period of time where we really weren't concerned with pollution at all. And, we denied acid rain and things along those lines for a long, long time. So I guess I've got 2 points I want to make. I think geoengineering is inevitable. I really want to stay away from the aerosols, and I think that Myron's ship idea would work, but again, I don't know what putting that kind of concentration of seawater in the lower atmosphere would do long term wise. I could see some negative consequences, but I just don't know. So I think we should look towards space and look at mitigation strategies moving towards those directions. Because one thing's for damn sure, we're not going to change the power dynamics before life cycles have run their economic courses anyhow. I don't see any indication anywhere that that's the case.
I think you're right. And I appreciate your mentioning space and a well-positioned mylar or something like that, principally covering the southern hemisphere, blocking solar radiance there, would have less impact on food production and other solar uses, while still very significantly cooling the planet. But it would have to be carefully positioned. Or two, one to protect either pole and try to return the colder at the poles and thereby keep the ice locked up there. Something like that. I like your idea. Yeah, there's a lot of merit there.
Okay, anybody, Dave or Brendan, Saeed, would you like to join in?
I've sort of said my piece a little bit earlier, halfway through. There's other questions I have about it. I just think that when looking at the environmental impact, there's so many different metrics involved in the 13 different potential solutions you threw out there. I just wonder about if there's ever, a sort of defeater impact. So in philosophy, a defeater is when there's something that negates any sort of beneficial impact, whether short term or long term. And I guess I wonder what the defeater would be in terms of environmental impact for evaluating the effectiveness of this kind of method of geoengineering. But I think it's an open question, and this is a jumping off point into that topic. I thank you, Richard, for sharing.
Maybe you'd like.
Basalt is a great choice because its worst downside when it strikes the surface, it settles out and it's done its thing in the atmosphere, is to do another really good thing and absorb some CO2 on the surface.
Right.
And and simultaneously feed phytoplankton and other surface microorganisms, which that's not bad either. So if we're going to do aerosols, basalt is probably the real way.
Okay, what do you think, Dave?
We're not gonna do aerosols.
What do you think?
Just forget it.
What do you think?
Okay.
Let Dave have a shot.
Well, the major problem I see is it's going to cost a lot of money. Who's going to pay for it? If you had a council of all the nations in the world, the logical choice would be the people who created it. And I don't see those people being willing to spend the money to fix the problem.
Actually, I really don't think that, I don't think the economic problem is the problem, because you've got enough rich people and you got enough real estate owned by the rich people who say, well, I've got $100 trillion of real estate. I'd be willing to bet 10 trillion to try something. And if I can give a 2% effect, I'd be real happy. I don't think the price is the problem. I think the problem is that the multiple problems, which technology doesn't backfire and cause bigger problems. And assuming you think you've got that, like maybe with basalt or salt water, and then how do you get enough of it effectively? Because basalt's heavy and salt water doesn't go very high. But I don't think that's the problem. And the other thing I was saying is, if it started to succeed, you get this feedback loop of people saying, oh, well, I've got my remediation machine over on the right, so I can make as much carbon dioxide on the left. And so that's what I was talking about. Invention is a mother of necessity. And so we're going to wind up having these machines that dim the sun to try to compensate for the people who want to run fossil fuels. We won't get
but hold on. Yeah, but we've got another angle to think about when we're asked the question of cost. You need to point out to these rich people who have a lot to potentially lose and say, okay, you don't want to spend the money for this, but what good is your money when we're all dead? And what is the cost of complete failure? Right. It's an infinite cost. It's not some fraction of what you own. It's everything, your life, your grandchildren, the whole shooting match. And we are getting, blind. We're getting to the point where that is realistically visible in front of us blindingly fast. We used to talk about hundreds of years. Now it's
called accelerationism, and the billionaire class has already embraced it.
Right. Yeah. And they're going to do something, whether we like it or not.
That's right.
And if it succeeds, it's going to create a feedback loop where you're going to do it more and also justify, well, I'm doing this so I can run fossil fuel plants over here. You remember the people who are buying green credits and then they build AI machines? Well, I've got my green credits. Therefore,
I think the only way the only way we stop that is to just transition off our goddamn selves and just say no. Just stop buying it. If we're not buying the fossil fuels any longer, well, guess what? They don't have a choice. They're gonna what? Use all of that oil to make plastics, I guess. And we're drowning in plastics now. Yeah. So, I mean, in other words, vote with your wallet is my point.
Well, I don't know that we solved anything tonight. We certainly created some provocative thoughts.
Yeah.
And if anybody, and I think Brendan suggested he has some kind of philosophical way to think through this. And if you can, write us an email, make that the topic of our next meeting. Remember you were talking about a philosophical way of treating the negative?
Sure.
Okay.
Yeah.
Before you guys leave, I mentioned this to Myron the other